Hello everyone, welcome to Pepcoding. Today we are going to solve a question named intersection node in two linked lists using fluid cycle method. Okay, so previously we have done the same question using the difference method. In that question also, what we are given two linked lists and we have to find the intersection point of those two linked lists. Okay, so the previously in difference method we have used the difference like some strategy to find out the intersection. In this question we are going to use the fluid method. So we are given two linked lists here. First of all, let's go and draw two linked lists. So this is the first linked list. Just imagine. Just goes here, here, again. Next node. This is it. Now let's draw the second linked list. Just suppose this is this, then this, then this. After that, this. Okay. So this is linked list 1. This is linked list 2. This point is the intersection point that we have to find. Okay, intersection point which we are looking for. We have to use the fluid method to detect this point. This is the head 1 for this. This is the head 2 for the head of linked list second. Okay, actually I should draw this linked list 2 with different color. Okay, so let me do that. Okay, so it will be more attractive, you can say. I have to change color. So let's go. This is here, and this, and this, that this, and then at last this. So this was the second linked list. After that, the same length, linked list continue here after intersection point. Okay, so we have to find out this point using fluid cycle method. So actually now let's go and see how we are going to do this. As I have told you, this is head 1 and this is head 2. What is happening now? What we will start iterating either from h1, either from h1 or from h2, and we'll iterate till we reach the last tail of the list. Okay, so let's go just start iterating. So just suppose we are start iterating from h1. We came here. After that we came here. After that we came here. After that again here. After that here. After that here. After that this point. After that this point. After that this point. After that this point. So here we reach the tail of this linked list. Okay, so now after this what we have to do, we have to attach this tail with this head of the second linked list. Okay, so just suppose if I do this, what will happen? So this is now a circular linked list, you can say. So what problem this became? This become this problem, like the in the previous question in which you have solved that starting point of this cycle in the linked list. Okay, so it became that question. This will be the starting point for this cycle and that is our intersection point. Okay, and we already have done this problem, so it is becoming very easy now for us. We just have to start iterating from head 1. We have to reach till the tail. After that we have to connect it with the head 2. Okay, there is a link for that question in the description and you will find that video on the channel. Just go and watch that video first, so this question will be easy for you. Okay, so I'm assuming that you have watched that video. Okay, now after doing this question became very easy. Let me erase this, then we'll move forward. Okay, so and one more thing, don't forget to detach this link after completing your question. Like when we get our result, this intersection point, while returning the answer, don't forget to do this. Okay, because we need the list back as it was given to us. Okay, so whenever we will returning the result, we will make sure that this link is broken. Okay, so before that, now let's move forward towards solving the question. So after doing this, after iterating up to the tail and attaching it with the head of the second list, what we will do, we will attach a fast and a slow iterator here. After that, what we will do, we will start moving it until I find it at equal point. Okay, so what happened, let's move them forward. First of all, slow will move. Okay, it will move one step forward, fast will move two step forward. Again, S will move. Okay, I think we missed something. We missed actually nothing. Our fast iterator moves first and the slow moves later. Okay, so the fast one moves first two times, two steps, and slow one moves one step. After that, F again moves two steps, and S1 moves one step. After that, F again moves two steps, and S moves one step. After that, again F moves two steps, and S moves one step. After that, again F will move two steps and S will move one step. After that, again F will move two steps and S will move one step. Again F will move two steps and S will move one step. After that, again F will move two steps and S will move one step. After that, again F will move two steps and S will move one step. Okay, so at this point, what is happening? F and S are equal. Now what we are going to do, after that, slow pointer is again going to at the start point. So it will start and go at the start point of the linked list. After that, what will happen? We will start moving both the pointer with the same speed. Okay, so now S will move with one step, F will also move with one step. Now again S will move with one step and F will also move with one step. S will move with one step, F will also move with one step. S will move with one step and F will also move with one step. Again S will move with one step and F will also move with one step. Again S will move with one step and F will also move with one step. And at this intersection point, they both will meet and will find our intersection point. Okay, and then after that, what will happen? We will return this intersection point. And don't forget, before returning, we have to detach this link. Okay, तो अब हम क्या करेंगे, इस लिंक को डिटैच कर देंगे क्योंकि मॉडिफिकेशंस अलाउड नहीं है. Okay, so this is done. We have removed that link. Okay, now what we are going to do? Now we are going to code the same strategy that we have followed here in the theory. So let's go on the editor and write some code. So this is the editor. Now let's go. So here we are going to write one more function for finding that starting point of the circle from where we will find this point, the intersection, this one point. Okay, as we have discussed in the Floyd method. So let's go write that method first. Public static list node starting of circle. Okay, inside this we have a node, so list node head. Okay, this is done. Now as we entered here, we will check the head that it is not null. Okay, so if head is equals to null or head dot next is equals to null, what will happen? We will return null because no intersection, no start of the circle is possible in one node or no node. Okay, so let's move forward. Now what we have to do, we have to define one fast iterator and one slow iterator. Okay, so list node fast equals to head and list node slow equals to head. Now what will happen? We will start moving these fast and slow iterator. Okay, so let's move. While fast is not equals to null and fast dot next is not equals to null. So this is done. Inside this, what we are going to do, we are going to move the slow and fast iterator. So slow is equals to slow dot next and fast will move with twice the speed, so fast equals to fast dot next. This is done. These both are moving with 2x speed. Now fast is moving with the 2x speed. Okay, now what we are going to do, so we will check that condition where they both met. You remember when they both met at here some point. Okay, when they were moving, they met at some here point. So for that, whenever the slow is equals to fast, what will happen? We will break this loop. Okay, this is done. We will come out of this loop. Okay, now what after coming out of this loop, there's two conditions to come out of this loop. One is slow is equals to fast, and other is fast is equals to null. Okay, so we'll check if we came out of with this condition. If we came out of this slow equals to fast condition, it means what is happening? We have met at a point. So we will check if slow is not equals to fast, what we will do? It means there is no cycle present, so we will return null from this point. Okay, and we come out of here. If it is equals to, then what we will do? Then we have to also do something. If they both are equal, then we have to send the slow iterator at the head, and we have to start moving both the pointer with the same speed. Okay, so after this, what will happen? Slow will go to head. Okay, now after this, what we have to do? We have to start iterating again. While until when we have to start? Until they both become equal. So until slow is not equals to fast, what we'll do? We'll move with the same speed. So slow equals to slow dot next, and fast equals to fast dot next. Okay, these both things are done. Okay, so after coming out of this loop, what will happen? We will get our intersection point. So we will return that point from here. Okay, either we return for fast or we can return slow. Both are the same answer because they both are at the same node right now. Okay, so with this we get our intersection. Now we have to deal with this function. Okay, so in this function, first of all, what we will do? We will check for null. If head A is equals to null, or head B is equals to null, what will happen? It means no intersection is possible because one of them is null or maybe both of them is null. So we'll simply return null. Okay, this part is done. Now what we are going to do? After that, we have to start iterating from the head of any of the lists and reach up to the tail. Okay, so we are here, list node tail. First of all, we will put it at the head of A. Just suppose we started from the head of A. It doesn't matter, either you can start with the B, the tail will remain same. Okay, so we got that. Now what we have to do? We have to iterate the tail until it reaches at the end point. So while tail dot next is not equals to null, what we'll do? We will make tail move forward. Tail equals to tail dot next. Okay, this is done. When we come out of this loop, what it means? We have reached to the tail of the linked list. Okay, now coming out of this loop, what we have to do? We have to attach this tail with the head of the second linked list. Okay, so tail dot next is equals to head of B. That is done. And please don't forget to remove these changes because we are not allowed to make changes in the given list. Okay, so tail dot next will be equals to null also after some time, after we get our answer. Okay, we will do this. Okay, so after attaching this, it became the same problem, this one. Okay, where we have to find the starting point for this circle. Now let's go on that. Okay, so here what we will do, we'll make call to our this function that will send at the starting point of the circle. Okay, yes, let's copy this name of the function and let's move forward. Okay, so what we'll do, where is the function? Yeah, we are here. Okay, so we will make a list node to store the answer, which is here. After that, we will make call for that function with node of head A. Okay, because when we make circle, what happened? This point is this point, that is head A. So that's why we send the node head A. It will send us the answer. Okay, so this is done. Now we have to return our answer from this point. Return answer. So this is all code about that we have planned. Now let's go and run this code. Okay, yes, there is some typing mistake at line number 17 here. Hi. Now let's go run this again. Okay, again some typing mistake, I think, at line number 41. If head A equals to, okay, mistake, it was all in the capital. Now let's run this again. And yes, it is accepted. Now let's submit this for all the test cases. Okay, yes, 10 by 10. So I hope you have liked the video. Please share and subscribe. Please share the video and subscribe the channel. Thank you so much for being here. I hope you have learned something. Thank you so much.